Well, hello. And we should be live for another Quarkus Insights, right? So let me just make sure that everything's going fine, hopefully. Maybe not. So give me a sec, just making sure. I think we should be good to go. Okay, so anyway, sorry about that. So again, welcome everyone for the episode 193, Quarkus Insights about observability. So before moving forward, I'm going to be the host for today. So really sorry for I haven't done this for a while, so I'm still trying to figure out the changes on the stream side. So before meeting our presenter for today, which is Bruno, I just want to give you a couple of Quarkus news. So last week we released 3.17.8, which is one of the maintenance releases on the 17 stream. And next week we're going to release, actually this week, we're going to release 3.18, which is going to be a new minor version. And it's going to be like one version before 3.19, of course, which is going to be the basis for the LTS. And why is that important, right? So 3.20 is going to be the next version for LTS Quarkus. And that's important because if you want to have big features coming in, they're going to be required to be on the 3.19 branch because that's the one that's going to be used as a basis for the next LTS version, which is 3.20. So if you're looking really to have something big or some new features coming to Quarkus, they have to go in the 3.19 branch. So go on GitHub, vote on some of the issues, get your pull request ready for 3.19 because that's the version we're going to use for the next LTS on 3.20. 3.19 is going to be, it's scheduled to be on mid-February or late February, almost in a month now. And then 3.20 is going to be in March, around 2 months from now as well. So those are the news regarding Quarkus versions that I wanted to give you. So without any further delay, I would like to welcome Bruno to the stream. So let me just add Bruno. He's been listening to us, but he's here hidden. Hello, Bruno.
Hello. Good afternoon or good morning.
Yeah, thank you so much for joining us today for this Quarkus Insight. How are you feeling today?
Very well, very well. And yourself?
So I know that you've been working a lot with the observability in Quarkus.
Yeah.
Right. So this is not really new for you. You already done a couple of insights in the past about the observability, but we also know that's a very rapid moving space, right? So I'm guessing that you have a lot of news on what Quarkus has been doing around observability in the last couple of months, maybe 6-7 months, I don't know, right?
Yes. So there's quite a few new things in Quarkus related with observability since then, and we are going to go through them on the presentation.
Wonderful. Okay, so without any further delay, the stage is yours. Let me have your presentation here for people to watch. And there you go.
Okay, so thank you very much for being here, and welcome to Observability and Quarkus. We are going to talk about what's observability, how it's implemented in Quarkus, the latest developments, and we are going to do a dive in on some code and see the latest things that we've implemented, and also a vision about where we want to go soon. So observability. A definition that I like a lot is the capability to allow a human to ask and answer questions, in our case, for a particular system. It aims to provide a holistic view on the system's behavior, and by system, I'd say a large deployment of microservices or even a single service, if it's your case. It's directed to complex environments, and works best when there's some collaboration between the developers and DevOps guys. What's the main differences between observability and the traditional monitoring definition? So observability is more aims at the complete understanding of this internal system, whereas monitoring was more about predefined metrics and understand the health and availability. It's more proactive in the sense that you should be able to answer questions that you didn't figure out before you deploy the system. So it has to be flexible enough to answer questions that you come up on the fly. And it's about managing complexity, because classical monitoring didn't have the visibility between interconnected components, something that we achieve with observability with the traces. So typically, the typical definition of observability divides signals into different types of signals. Well, the metrics, the logs, the traces. There's talks about events and also profiling and many other types of data that can be added to our telemetry streams. Then we can create visualizations and alerts. So, and how is this vision implemented in Quarkus? So in terms of logs, Quarkus uses JBoss Log Manager with some adapters for your preferred logging framework, so Log4j, SLF4j. There's a bunch of them, and all of them are now available on OpenTelemetry logging. So once you add the OpenTelemetry extension and you enable the OpenTelemetry logging, you will have a feed of your logs over there. For metrics, Quarkus allows Micrometer metrics with auto-instrumentation. So all our current metrics, automatic metrics, are implemented with Micrometer, and has a default output format with Prometheus registry. Right now, we also have OpenTelemetry metrics. It was added since the last insights that we had, and you can now create manual metrics on your application with this API. And we also added a microprofile metrics compliance, meaning that we have HTTP server requests and JVM metrics generating automatically metrics with our extension. And finally, what we had before, which was OpenTelemetry tracing, that we continue to evolve. So that's what we have currently. But let's explain in more detail each one of the extensions. So Micrometer is the de facto metric standard in Java. The API that it defines allows some independence of the monitoring system that you are going to use. So the APM where you are going to send the telemetry has a rich set of types that you can use. So counter, gauge, timer, histogram, and distribution as a distribution summary, and long task timers. Tagging for dimensional metrics. So you can define the app name as one tag, the request response as another tag, and the route, for example. And all these will give you particular metrics for that set. And is Java only. So, and this is how you instrument the Micrometer Quarkus extension. So how you add it to the POM XML if you are using Maven. There's also an example of the application properties that you can use, and all data will be available on the /q metrics endpoint. And what usually is done is that the Prometheus scraper, which is a functionality in Prometheus that goes to that endpoint and gets all the metrics from time to time. And with that, you can query Prometheus and generate your queries and dashboards and everything. So, and then there's also OpenTelemetry. OpenTelemetry is multi-signal in the sense that it has allows metrics, traces, logs, and a bunch of other things. As I mentioned before, there's OpenTelemetry has work on events and also on profiling. And it provides a specification, standard set of APIs and SDKs, semantic conventions, so basically the meaning of each of the metrics and the meaning of all the fields in all the signals, the different signals, and also a standard way to transport data, the OTLP protocol. And it's not just for Java. So there's different maturity of the implementations according to the programming language, but you will be able to use the same APIs and standards on multiple programming languages. So if you have a system that has services implemented with Java or Go or Python or so on, depending on the maturity of that implementation, you will be able to have the same telemetry going out. Okay, so OpenTelemetry doesn't care about data ingestion. So it's just creating the data out and sending out of your application. It doesn't care about how it's visualized or how it's stored. So that's for the ingestion systems to care about. The main components that we care about in relation to Quarkus, so the specification that we talked earlier, and then the Java implementation. So the OpenTelemetry Java implementation that has the Java API and SDKs, and some extensions like the OpenTracing shim. In the past, we supported OpenTracing. So there's this shim. It's basically a bridge for someone that is using OpenTracing to send data using OpenTelemetry. Also, the OpenTelemetry Java instrumentation that has a particular API just for instrumentation that only happens in Java, and with that, some libraries are instrumented. And there's also there the Java agent that we don't use in Quarkus for some reasons. One is that it's not possible to use in native mode, and also there's a performance overhead that makes us to prefer the extension instead of the Java agent. So there's also the semantic conventions Java with the semantic conventions implementations for Java, and other projects like Contrib and Docs. Finally, there's this OpenTelemetry collector, which I'll show you on the next slide. So if you have your application in this box here, the Java instrumentation API will create the telemetry that is handled by the OpenTelemetry SDK, and then it uses an exporter to send out the data with the OTLP protocol. This data can be sent directly to the vendor if they support OTLP, or it can be sent to a collector that can perform additional processing and has their own exporters, quite a large amount of them, I must say, that can also talk OTLP or any proprietary format from other vendors. This collector usually it's implemented as a sidecar for container distributions, or can be implemented as a cluster and receive telemetry from many different services at the same time. So it's a nice utility. OpenTelemetry in Quarkus can be used with this extension if you are using a Maven project. And this is an example property. This is actually the default value where things are sent. And since recently we have, as I mentioned, OpenTelemetry metrics, logs, but they are disabled by default. To enable them, you need to actually use those properties in the application.properties file, so they start to generate data. There's other exporters for OpenTelemetry. So in this particular case, there's an Azure cloud exporter. If you deploy applications on Azure and you want to send telemetry specifically for the Azure Insights, you can use this exporter. That also includes the OpenTelemetry extension. It's an all-in-one. So there's other extensions related with observability. So this one is the Quarkus logging JSON. It will produce structured logging in JSON format in the output. But well, no one wants to read JSON when doing dev mode or tests. So if you set the dev mode and tests, the logging will be human readable with this configuration here. So we have many extensions with different outputs, and we want to work on unifying all this telemetry. So we would like to have one extension to rule all observability, and something that would include the Micrometer metrics that provides access to all the automatic metrics that we produce with Micrometer. OpenTelemetry metrics for people that would like to instrument or create instrumentation with it. The OpenTelemetry tracing, logging, and we want them all by default, on by default. We also want to unify the telemetry output, so we can use our Vertex-based OpenTelemetry exporter using the OTLP protocol. So that's what we would like to do, and that's what we implemented. So we have a new extension. It's the Micrometer plus OpenTelemetry extension. So let's instrument a project. I don't know if there's some questions or someone wants to say something. Roberto?
Not at the moment. You can carry on.
Okay, so let's go. So if you go to Code Quarkus and create a demo project, let's say with REST, I usually use REST with Jackson, and I generate the application. So I did it before, and with that I created this application here that I have that will have a demo greeting endpoint with a hello. Well, I forgot to remove this. Let's add it later. That just returns this string when we query the hello endpoint, and has some tests and some basic dependencies like REST Jackson, the dependency injection, and pretty much testing stuff. So if we want to add the new extension, so we can go to the documentation of that extension. So we can go to the docs. So it's on main. So this extension that I'm showing you, I'm going to show you, will only be available on Quarkus 3.19. So, and if you want to use it, you just need to add this dependency, or if you have the Quarkus CLI, execute this command that I actually like a lot. So if we go here, it added the dependency here. So let's just start Quarkus in dev mode. So right now, what you can see is that we are having an error. So we seem not to have any place to send the data out. Well, and that's because we don't. So we try to send data. However, we need a collector in this case to receive this information. And so we had this in the past, just for logs, we had a Jaeger backend that we could start. But in the last Insights, we introduced something that we started to use, which is the Grafana LGTM dev service. And this Grafana dev service, let me explain what it is. It's basically an all-in-one with a Grafana that includes a Prometheus database, a Tempo database for traces, and the Loki database for logs, and also includes an OpenTelemetry collector. So what will happen is that our application, because it's instrumented with OpenTelemetry, it will know how to send out OTLP protocol data to these ports, and the OpenTelemetry collector inside the Grafana LGTM will forward to each particular database the right data, and then we can query it with the Grafana. So this is done in a container. So this is a dev service that starts a container with all this, and of course the ports here will be all random. And what our extension does is basically configures whichever extensions we are using to use the right ports to send the data. So let's see where that is. So
before
the output.
Before you go that, I think we have a question here that
yeah,
the context. So Spendus is asking, so if he's understand that correctly, both Micrometer and OpenTelemetry are on the same extension, correct?
Yes. So this new extension has both at the same time.
Then he has a follow-up question, which is, well, why are they separate extensions?
So that's why I started by explaining them individually, because they started at very different steps. So Micrometer is quite older than OpenTelemetry, and we started to develop all the instrumentation for it. Then OpenTelemetry started. Before OpenTelemetry, we even used the Open Tracing extension for tracing, if you remember, Roberto.
Yeah.
And we don't use it anymore. So they are effectively two different sets of libraries that are very different between them. And what we did here was include the Micrometer extension, include the OpenTelemetry extension, plus a bridge, so the data from Micrometer is handled by the OpenTelemetry SDK. So this allows us to send all the data through a unique channel with the OTLP protocol. That's what we are doing here. And that's why we were able to create this new extension that has everything. Because they are very different. They have different APIs. They are different projects. Well, they are very different.
Okay, I hope that makes things more clear. Do you mind going to the slides back again to the graphics you were showing?
Yeah, this one.
Yeah. So there is a further question, which is, well, so saying that shows OpenTelemetry collector sends data to Prometheus, isn't the other way around?
So that's the beauty of the extension, because with Prometheus you do pull. So Prometheus pulls data from the applications. When we do OpenTelemetry is push. So it basically grabs your data and pushes it somewhere, and that's what we do. We send it to the OpenTelemetry collector, and data between the OpenTelemetry collector and Prometheus will flow, and we don't need to care about it.
Okay, that sounds nice. So I hope that that clears some of the questions the pandas follow. So thank you for the questions. Please keep them going. So Bruno, you feel free to proceed.
Okay, thanks very much. So we have this problem and this solution. So I was showing you that in the new extension, if we go here, see the output, we have this Grafana LGTM dev service, and when we click there, we are taken to the guide for that dev service. We are going just to grab the dependency here and add it. And now we have a place where data is going to be sent. We are going to grab it on the Grafana LGTM dev service. So as you can see, the container is being started. It will run these versions of the services inside, and it takes some time to start. You can see here that it's on this endpoint, and it's already up, but it's still starting the underlying service. So we are going to wait. We don't want to mess anything. So I see some questions here. So someone is asking that if we use Grafana Cloud. No, this is running locally. So this is a dev service that starts a local instance of the Grafana LGTM with all those services and runs on your machine. If you own a Grafana Cloud, well, I imagine that if you point to the Grafana Cloud endpoint, you will see the same data. So that's actually an advantage. You can actually develop locally and see the same outcome as in any cloud, if you have a Grafana. Okay, so it started. In the end, it shows this. So basically the ports but these are the ports that are open inside the container. So as I mentioned, the dev service actually translates those ports into what we can see outside. So that's why the Grafana is on this weird port. Well, we do that mapping. Also, we also map the collector ports, so everything works transparently. So, and so this is a normal instance of Grafana. I haven't done anything yet. I'm just going to show you what's going on. So usually we go to explore. Prometheus will have the metrics data here. If we go to tempo, we will have the traces. And if we switch to Loki, we will see logs here. We are not seeing anything because I haven't select anything, but we'll do that in due time. So, and we have created a bunch of dashboards. So we have, so this dev service is not just if you use this new extension. If you use the current Micrometer metrics Prometheus registry, you will be able to see metrics in it with this dashboard. If you use the Micrometer Quarkus OTLP registry, you'll be able to see it here. And if you use the new extension, you will see the Micrometer metrics on this new dashboard. Okay, so this is where things are, basically. So let's go to our code and do something. So because we are in dev mode and, well, we can, let's do here a live reload. We'll add a log line. So I had it here before, but well. Yeah, so help. So we want gbos logging, and we are going to do log. and something like request received or something, receive request. So now when we call the endpoint 8080 hello, so hello from Quarkus REST, and we have here the receive request from the log line that we added. And now we are going to try to find this log line on Grafana. So we have Loki for the logs, and we select our service. So it's called Code with Quarkus. And here they are. So we have all the log lines since Quarkus was started. So let me go a bit lower. So it started in, well, 37 seconds because it's also started the Grafana dev service. So it took a lot longer than usual. All the lines that we saw in the log before here. So basically all these lines are ending up on the Grafana dashboard. So, but it has much more. It's not just a simple log line because it's using OpenTelemetry, it will have context. So it will have the method. So this is the OpenTelemetry semantic convention. Well, at least at the moment that we wrote the code, because these conventions are being updated, and I know for sure that this is going to change soon, if it hasn't changed already, at least on the spec. So the function is the method. So it was a hello method on this class, on this line of code with info. So we use this logger and a bunch of information about the context, so the application name, the version. It was instrumented with the OpenTelemetry, with the Java SDK, so it's a Java service. And we also have the thread ID, the thread name, and also very important, we have the span ID. So we have information about the trace that was used to track this particular request. So when we click here in trace, we can see that trace. So if we go here, Code with Quarkus, you have information about that trace. So this particular one took 5 milliseconds. Well, and here you have the information, the status code, the route that was used, and even the agent that did the operation. So, and we can do the other way around. So logs that have this span on it. So we only have one, but you can, if we had more log lines that that mention that span, they would also show here, and you could have basically a list of all the logs that make sense of are related to that request, which is super handy. So let me close all this stuff somehow. Okay, close. Of course, if you want to see all the logs, you can go here, search. Yeah, and you have this request here. We can do a few more just to generate data. And let's wait. So data is not sent right away, but because we are in a local environment, we also tweak the delays so it's faster. So usually in production, it takes a lot longer for data to be sent out, because it tries to aggregate more to save in the calls. But in here, we speed up things, so you don't wait so much time waiting for the traces. So that's something handy with the dev service. Okay, so I think we have some other questions. Let's check.
Yeah, I was just waiting for you to finish what you're saying before posting the questions. Okay, so again, this is coming from Stupendous Follow. I think that's how you pronounce it. So the question is, how does OpenTelemetry collector collect logs, metrics, and traces? Does Quarkus push to it, or does the collector pull?
Yeah, so it pushes. So remember that this image? So the app is on this side and pushes data out of the service using the OTLP protocol into the OTel collector that's inside that container. And the container has the rules to send out the right signal to each database. So if it's a trace, goes to Tempo. If it's a log, it goes to Loki. And if it's Prometheus, well, it ends up on Prometheus. So we do, however, a small cheat, because remember that I mentioned you that we had a dashboard for Prometheus. So this Micrometer Prometheus registry publishes data on /q metrics, and it doesn't know about the OpenTelemetry collector. It doesn't push data. So what we did, we changed the configuration of Prometheus, and whenever you have this registry on your class path, we actually start a scraper on Prometheus and go there and scrape data. That's why we have a different dashboard for it, because data will look different, because it follows a different semantic conventions than the ones that we get out on the Micrometer OpenTelemetry extension that does the pushing. So there's this small difference. If we use Micrometer OTLP and the Micrometer metrics OTLP registry, we push data to the OpenTelemetry collector. If we use the Micrometer Prometheus registry, we actually configure Prometheus to get the metrics. But if you use OpenTelemetry also on your class path, and let's say that you have multiple dependencies, the push for the other signals will also use the collector. I don't know if that was good enough.
Yeah, I believe so. So there's a further question, which is, you mentioned that the OpenTelemetry spec is still changing, right?
Yeah.
So will you say it is stable enough to use in production?
Well, like everything in engineering, it depends. It depends on your expectations. And if you want to have very complex dashboards and queries, because if you are going to use, so to be fair, HTTP semantic conventions are stable already, and they should not change. But everything else is up for grabs. And like the line number and the method name and things like that, they were changed or going to be changed really soon. And that happens also in other fields. But the expectation is that as time moves along, these changes will be rarer, they will happen less, and you can start to have more stable dashboards. But the problem here is that different semantic conventions will generate different queries for your dashboards, so your dashboards will change if the convention changes as well. So that's the risk. If you don't have complex dashboards, it shouldn't be such a big problem. But again, each time a convention changes, you have a time. Either you have both conventions in tandem, so you duplicate the data, or you need to do queries. If you want to have large span of time, you'll need to do queries until that date and after that date. So it makes things a bit difficult. But yeah, it's what it is. And that's the main reason we are still using micrometer metrics, because the semantic conventions there are very stable. I hope that answered your question.
Yeah, I believe so. Excellent. So for the time being, I think we don't have any questions, but keep them going. I think it's being a really interesting conversation. But I believe you have a couple of more things that you want to show us, right, Bruno?
Yeah. So I was here spending some times on the traces and the logs. Let me show you some other things. So we will have, let's say, localhost. So legumes. This doesn't exist. So we will have Quarkus in dev mode will show you this pretty screen. And if you want, you can go to the dev UI as well. So the dev UI will have details about all the extensions that you are using. But what I wanted was just create a new request. So, and that request goes here. So I called legumes, but it shows slash. Let's see why. So basically what we have here, let me put it a bit bigger, is we have a 404, so page not found. So we called legumes. It was a 404 because there was no route that we could route to, so it ended up in slash. And so basically every time you find an endpoint that you couldn't found, the route will match slash, because the route is used for the name of the span. And yeah, that's what it is. You can still have the URL that was called, but what's important is the route name here. And this was important because it will create more data to the dashboards that we are going to see. So let's see the dashboards. So we started this 15 minutes ago. It's using not that much heat, but this machine that I'm working on is huge. So it shows 5 minutes. Let's increase to 30 minutes. So we have some data here. And it will get you the total number of requests. So some of the graphs here need some explanation, because the values are calculated in a 2-minute sliding window, and the same way it takes some time for the data to show up. Then it has a longer tail, so for the data to refresh. So we have here the average inbound request duration, so 7 milliseconds. The maximum inbound request duration, the sum of every request in the time window, and so on. So please mind that these values are still experimental. What you are seeing here is not yet on main. Actually, it's not yet in a pull request. I'm going to open this pull request this week. So we already have these dashboards in main. It will be released as part of 3.19, but we are still working on it. We are doing some iterations to improve and refine the whole experience. So a lot of people have been contributing for these graphs. So I can mention Marco Bungart and also GitHub user Melloware that have worked a lot in these dashboards, and I want to thank them for that. So more information. JVM memory. So you can see that the total JVM memory, it's around, the used is around 272. So probably this is too small. I don't know what will happen when I increase this. Yeah. And the max is 9 gigs because I have a 32 gigs machine, and well, it's the max is, I'm using defaults here, so I'm not tweaking the max. Heap, non-heap, the CPU usage. This is not the process usage. This is actually the machine usage. So if you are using a container to deploy your application, it will show you all the CPU that's being used on that container, either be because of your service or other things that are running in there. Same for the load. The threads, file descriptors. I'm not using JDBC, so I have no data here. But if you are using the JDBC instrumentation and you enable the telemetry for metrics and traces, well, traces, you will have traces also for JDBC. If you enable the metrics, you will have data here about your queries to the database. Memory pools, and so garbage collection here. The number of classes that are being loaded. Buffer pools, and also we have, well, we don't use GraphQL, but if you use GraphQL requests, they will be here as well. So let's go again to the Explore. So all the components on the dashboard that you saw can be also accessed here on Prometheus. So you have all the metrics being produced here, and there's this nice metric explorer. Let's say active requests. Let's say HTTP server. Oh, this is a count of all the requests. So this was what I wanted to show, but it's showing a bit big. Well, yeah, it's good. So in this case, so we have a get that was a success. Yeah, this way is better. And it was the 200 for status, and Micrometer instead of target shows URI, but it's the target that you see here. We had 4 requests there, and there was a not found. Well, we don't say which URI we set there because, well, if you have too many, you will have too many values in here, and we don't want that. We don't want that type of data on a metric. So all the values that should be on tags, it's how Micrometer calls these are tags, and attributes in the case of OpenTelemetry. They need to be low cardinality attributes or tags, because by low cardinality, I mean they need to have a restricted amount of different values here. Because if you have many different values here, you will have to represent all that data in memory many different times, and in the end, you are going to blow up your memory. So in Quarkus, we have a restriction that will limit the number of different tags to 100, and that's a configuration. Actually, it's the configuration that I was showing before when I was talking about the configuration of Micrometer. Let me go back and see if yeah. So this one here. So this is actually the max tags URI. So I set it to 90 instead of 100 on this example. Yeah. So, and each different combination will get you a different line here. So you'll have all these graphs changing a long time. Okay, more questions?
Yeah, we have another one here. So with this one, it's about the dashboard. So you were saying that you can configure a few things there. So what about alerting? Can you add an alert when there is an exception happening?
Well, we are not. So this is dev service. This is for development time. So the dev service, the Grafana dev service is for someone that is developing an application that wants to create metrics, and basically you can check the metrics that you are creating here and see if they have the values that you expect, or even try to find problems in your code from the metrics and all the telemetry that is being produced. So this is for development time. Notifications and all that type of thing, reports and so on, should be for production. And Quarkus doesn't provide that. You need to pay an application performance manager, an APM, for those kinds of things, or you need to set up that infrastructure yourself. So notifications is a different kind of problem that we don't tackle here.
Excellent. I mean, we are approaching the end of the session. So if you have more questions, please feel free to post them now so Bruno can answer them. Bruno, is there anything else you wanted? So we don't have any more questions for the time being, but in the meantime, do you have anything else you want us to show us?
Yeah, let's go here more towards the end of the presentation. So in review, so I wanted to have I wanted you guys to have an idea of what observability is. At least there's a newer versions of what observability should be, but this is kind of the more broader observability 1.0 definition, the one that I gave you. So we talked about the new OpenTelemetry metrics and logs that are available now, the new Micrometer to OpenTelemetry bridge, or the new Micrometer OpenTelemetry extension. And I showed you the Azure exporter for OpenTelemetry that we have as well, and the new Grafana dev service and dashboards that last time we talked were planned, but were not yet in production. So most of the things that I've shown you are already in main, just small tweaks in the dashboards are not yet there. So, and next, what are we planning? So we want to support the observation API. So we want the observation API is a relatively new project from the Micrometer folks, and with this new API, you can basically create metrics and traces from it, and simplifies a lot the instrumentation of libraries. So we want to support it and see what we can do with it in the future. We want to have more dev services and OpenTelemetry exporters. So we have, I mentioned the Azure one. We have a Sentry one as well for people that use Sentry, and one for the Google Cloud, but it doesn't work on native mode, just JVM mode. And on top of all this, we are also working on performance. We want to make sure that of the performance impact of all these extensions in production, and we want to publish our results and make you guys aware of the best configurations and what you need to tweak in order to configure Micrometer and OpenTelemetry on a production environment, so you can squeeze the best performance from it. And yeah, so those are the plans for the future. These are the references for the guides and the projects on GitHub for the different things that we talked today. I don't know if there's some last questions in there, Roberto.
Yeah, we had a few. So So this coming from Martin. This new extension that you've been talking as well, so Quarkus Micrometer OpenTelemetry, will it be in preview for 320 LTS and the recommended way for hotel capabilities in next LTS?
So it will be on the LTS as a preview, of course. And, well, you should use it if you want metrics and the OpenTelemetry functionality. Because Micrometer metrics will provide that for you. If you just need OpenTelemetry and you don't need automatic instrumentation for metrics, you can just use the old OpenTelemetry extension. Basically, now we have 3 extensions. One for people that want to use Micrometer alone, one for people that want to just use OpenTelemetry alone, and one that want a bit of everything at the same time, because that was a very common use case. People would be adding both extensions, and then they would have to configure different endpoints to send data, and there's specificities, and they didn't play along. The data, they weren't communicating data to each other. With this new extension, if you want automatic metrics, OpenTelemetry, and send data to a particular endpoint with OTLP, that's your use case. So it's more flexibility for you.
Okay, I think that clears things up. We don't have any more questions. We almost at the end of the hour, so 3 minutes left. So, Bruno, if you don't have anything else that you want us to tell us in these last 2 minutes, I guess, let's just say goodbye to everyone that was here with us today, and thank you so much for all the questions that you've been posting. It was great to have you here, Bruno. It was great for you to show us all the work that you and other people have been doing in this space. So thank you so much for that. And
having me.
Yeah. And without any further delay, so again, thank you so much for all the audience. You can catch up this session later on. It's going to be available in all of our media as well. So if you want to catch up something that you haven't been able to see during the presentation, you can review it. And I'm pretty sure if you have any further questions, you can reach out to Bruno and other people from the Quarkus team on our usual media like GitHub, Zulip, email, and so on and so forth. So again, thank you so much for joining, and please join in again next week for another Quarkus Insights. So
Thanks very much.
And bye-bye.
Bye.